All right, guys, welcome to another episode of CUDA Education. I just wanted to finish up this hit value discussion because I am eager to move on to different topics. All right, so um, the thing about it is that we already figured out that if we sort of nullify this hit value variable, that we'll get a blank screen, right? So I'm gonna do it real quick again. So we're just gonna put in we'll just use CUDA education as a variable. We're gonna initialize it just like how the hit value was initialized. This is on the RayGen shader, right? Right, and then we know that currently we get we know that currently we get a triangle, right? So right, because we're basically voiding out this hit value. And remember, the hit value is the payload, but we're doing it on a different location. We're doing it on a different location, so we're basically just like voiding this hit value and voiding the ray payload and everything that everyone else expects, all the other shaders expect, right? So we're gonna compile the shader. I'm just gonna compile it to reflect these changes, and you'll see that we'll get a blank screen. So the I just wanted to finish out this hit value discussion. So now notice that we have I'm waiting for it to compile, so I'll just discuss. Notice that we have a closest hit shader, location 0, and we have a miss shader, location 0, hit value, and then these guys here. Okay, so what we want to do is, so notice that we get a blank screen, right? Which is expected. All right, so let's take out, so we know that if we null and void this hit value thing to a different location, different variable, everything basically the payload on the ray doesn't record anything, and there's nothing shown at all. Not even the miss value or the sky model or anything. Nothing is shown in the algorithm, right? So let's go back to basic. We'll recompile just to make sure we get back our triangle, and then we'll start to investigate the other shaders. So again, guys, location 0, and it's location 0 because that's where the acceleration structure is. The acceleration structure is at location 0. So this is all acceleration structure stuff. So the closest hit shader now, the closest hit shader is supposed to basically record that a hit has occurred and then assign a color. So this barycentric chords basically is supposed to help us assign a color to the places where there was a hit. All right, so we're gonna assign a color to places where right, we're gonna assign a color to places where there was hit, and and it makes sense. You see here we have our triangle. So if there was a hit value, we're gonna assign a color, and we could see that here. This is on the closest hit shader, right? We could see that wherever there's a hit, we get a specific color that's different from our sky model. Okay, so wherever there's a hit, we get a color. All right, and this is on the closest hit shader in this guy here. So the closest hit shader, right? So we notice that we get a hit. All right, so whenever we have a hit, we change the color of the pixel to show that there was a hit and what have you, right? So we're cool with that. Now let us let us try and retard this let us try and null and void this particular assignment. Let us try and get rid of this particular assignment. So what we're gonna do is we're gonna basically no matter what happens, we're basically gonna reset the hit value to 0, right? So here the hit value is set to a color, but then we're gonna reset it back to 0. Okay. So every time the closest hit shader is engaged, the hit value is reset to 0. So let's save it. Make sure it's saved, and then we're gonna compile the we're gonna compile again with basically the reset. I leave this in here just because I don't feel like taking it out, but we're resetting the value to 0, 0. So on the hit shader, anytime there's a hit, we don't have a value. We just have 0, 0, right? Everything is 0, right? And what do we get when we get that? When we do that? All right. So what do we get when we do that? Still have to wait. All right, so what do we get when we do that? Okay, so can you guys guess? What do you think will happen? If we're resetting the color every time, what do you think has happened? We basically get the hit, we record a hit, but then the color is, I guess, 0, 0, which is black, right? And it doesn't matter where on the coordinates it is, it's black. All right, so we still get the outline of a triangle, but it's black. Notice that this barycentric chords, it's doing a calculation based on, you know, proximity of the vertices and all that stuff, right? It's like special code to figure out what color to use. But here, no matter where the hit is, we're basically saying, okay, it's black, right? So I'm gonna guess that 0, 0, 0, 0 is all black, right? So that makes sense. So that is our hit shader, okay? So now things are kind of coming together. We understand that if we reset, you know, anytime there's a hit, it's recorded here, and we assign that to the hit value payload, which is our mechanism for communicating what's going on with that specific ray. So now let's do it on the miss side. So on the miss side, basically it says hit value is this guy, right? So let's just go back to normal. So I redid this thing to go reflect, you know, our normal triangle. I'll show you that we have a normal triangle again, and then we're gonna start playing around with the miss shader. Now, what is the miss shader? The miss shader basically says if the ray traverses through the scene and it doesn't hit anything, give it this color. Okay? So 0, 0.0, 0, 0.0, and 0.2 for the VEC3. Okay? We're going to play around with this to see if that's actually the case. So if we traverse, remember this is the miss now, right? If we traverse and we don't hit anything, give it this specific color. All right, so I'm going to assume that these coordinates represent this blue right here. Okay, but we're gonna play around with this. We're gonna play around with this. Okay, so we know that we're dealing with the miss shader now. We know that if we traverse the scene and we don't get a color, and we don't get a hit, we don't hit some geometry, we don't hit an object, we don't hit anything in the scene, give it this color. That's all this shader is. So let's do 0.9. Okay, so now I saved it. I'm going to recompile, and we're going to see if this truly controls what happens when a ray traverses a scene and we don't hit any objects. And then we'll be basically done with hit value. It's as simple as that, guys. It looks super complicated, but it's really simple. You know, it's it's not all that complicated. So I am just waiting for this shader to compile, and And that's all. So the closest hit basically changes the color to a specific color based on you know, a very special calculation, right? This guy right here, right? And then the mist shader is just one color, right? All right, let's see. So we're on the mist shader. We change the value to something else. Let's see what happens. All right, so look, guys, we get our mist shader is like completely different. Let's do 4. All right, so let's do a different color. All right, so that's all the mist shader is. Traverse through the scene. If you don't hit anything, this is the color of my pixel. While we're on the topic though, I want to make it a little bit more interesting. I want to do right. So let us okay, 4 doesn't really do anything. Let's try 1. Let's try 1. Yeah, let's just play around with this miss attribute. Yeah, I was hoping I could do something like creative with the miss value instead of it being one solid color to do like several colors, but this was what hitAttributeEXT. So this hitAttributeEXT is it's a special type. Yeah, it's a special type for when, you know, to stores interpolation data for a triangle hit. So it's a special type. We don't have an analogy for or an opposite of it for the mist shader. So the mist shader is just like a solid color. Right. So you see, guys, we have a different color again for the mist. Let's just do one more time just to be thorough. So I was trying to do like something creative for the mist, but I just rather not, I guess, at this point. because I would need the coordinates. You see, these are modifying the coordinates for the hit. So I mean, what am I calculating against for every other pixel? You know what I mean? Like, it just, you know. But anyway, it's all good. It's all good. I'm not complaining, guys. I'm not complaining. Right, so here we have a different color again. All right. Oops. So that's pretty much it's not that complicated. Like, I thought it would have been, like, you know, way more whatever, but it's actually not that complicated. It's pretty straightforward. Like, you know, we have this is the ray generation shader. This is what happens when you hit. This is what happens when you miss. The miss is super simple. It's just assigns a default value. So just to reiterate, we have our hit value. A hit value is a variable associated. It's a ray payload. So when we shoot out a ray, we have a variable or a payload associated with it, and then anything that happens with that ray is recorded in the hit value variable. So in the case of a miss, where we traverse the scene and there's nothing hits, we have a default color. In the case of a hit, we have like a special color based on calculations, this calculation here. And it basically uses the coordinates that is spit out by this hitAttributeEXT to make the calculation for the color, right? And that is pretty much it. So I had my new color. All right, well, I don't know. It's a similar thing, but I'll just put this back to 0.2. All right. And let me just confirm that my thing is back to normal. And that's pretty much it. So guys, if you want to be able to do this stuff, tutorial number 1, to install the Vulkan SDK, tutorial number 13, to install the all these examples, right? If you want the ray tracing examples, you got to make sure your GPU can run ray tracing. For NVIDIA, it's RTX and above. I don't know about AMD and Intel. The tutorial number 1 and 13 assumes you have a Windows-based machine with a Vulkan-capable GPU. Windows-based machine with a Vulkan-capable GPU. And then you could follow along with all these videos. You could do your own research, all of that good stuff. If you're creatively inclined, this is a perfect segue for you to put pixels on the screen and for you to, you know, basically apply your creativity in new ways and spaces, right? So I just want to confirm. All right. So our triangle is back to what it was before, right? We have our hit variable here, location 0, because it's associated with the acceleration structure, right? We default the value to empty, and then we push this hit value into image store. Image store is the storage buffer, which is the swap chain, and basically it records on the image, you know, any updates. So if the hit value changes, it's going to record on the storage buffer, storage image, not a storage buffer. It's going to record on the storage image, which eventually makes its way to the swap chain image, which eventually makes its way to the swap chain, which eventually makes its way to your screen, which eventually makes its way to your eyeballs. Okay, so the raygen is the hit value here is this image store thing, right? What happens when we hit something? When we hit something, we basically we have location 0. It's still hit value. And basically we assign it a color based on this calculation here. It's a kind of a special calculation because we use this hitAttributeEXT to find out the coordinates of where the hit occurred, right? So when you're traversing the scene, did it you know, where on the triangle did it hit? And then we assign a special color to do that. If it misses, we just assign a default value. So the background of the scene is basically this default value. And that's it. That's hitValue. So like and subscribe, tell your friends. That's ray tracing, at least in the raygen part in a nutshell, and also the miss and the hit. I don't know what else to tell you. So that basically covers, where were we? All right, so that basically covers these guys here. Obviously, we have to do a lot of processing to make sure that the everything is set up properly. But we have the raygen here, we have our miss group here, and we have our hit group here. Okay? And then we go on to other stuff. So I guess the ray tracing pipeline is the next order of business. And we have basically after this guy, we have about 230, 240 lines of code left. Okay. I'm not complaining. I'm not complaining. So right, the ray tracing pipeline, uniform buffer stuff. Okay, recreate the storage image, right, which is like recreating the swap chain. I did a video on this topic. Build command buffer. Right, notice that we have our resized here, so it's checking to see if the window is resized. Copy ray tracing output to swap chain image. Does this use a staging buffer and all that stuff? I don't know. Update so this update get enabled features. Prepare. So these are a bunch of like helper functions. We're gonna prepare stuff. Get enabled features. We kind of touched on this stuff. We have to make sure that that our GPU is able to do certain things. Helper function, prepare a bunch of stuff, draw, render, and that's pretty much it. So it's not too bad, guys. It's not too bad at all. I think we're making good progress. So let this kind of sit and we'll be back on it again. All right, guys, have a great day. Bye.